moon. Oh yeah, here it is. There's the nose. Here's the ears. I'll buy that. Almost looks like a panda bear. I think scientists sometimes, well, what you should hopefully when all the dust settles, you guys will be ending up doing something that you enjoy for the rest of your life. So I think scientists generally enjoy what they're doing too. Kind of some. Now this is the word tectonic. Where have you heard the word tectonic on Earth? Plate tectonics, yes. So again, kind of definitely has had in the past and most likely in the future some sort of geological activity. What country did I say has successfully landed on Venus? Russians, the Soviets, yes. And so actually, I didn't really like this picture. I thought, well, what other pictures are there out there on the internet? So I went ahead and went out to the internet. And this is just a Google search of various pictures of that landing. Now, you'd have to read about it and such, but I don't think it sent back information for very long. Okay, but that's kind of the landscape. Isn't that just a rush? Just like, oh my gosh.
Did it burn up?
No, it didn't burn up. It successfully, oh, you mean as it was sitting there, did it burn up?
Did it get like crushed? Did it like gravity?
Yeah, the gravity was an issue and the acidity was an issue. So, and temperature might have been an issue. So those three things, yeah. I'm not sure how it died, but I think that's neat. We get Mars, they get Venus. But actually, I think they've probably been to Mars too. When we talk about Mars, Mars is a very busy place. People coming and going all over the place. But with regard to Venus, if you're familiar with Earth's atmosphere, we have these terms. We have troposphere, stratosphere, and mesosphere. Okay, troposphere is closest to the Earth's surface. This is showing you troposphere closest, bless you, now to the planet Venus. So what does CO2 stand for? Carbon dioxide, yep. So when we look at the composition, let's go back to Earth. So as you're breathing in this air, what is the gas that you're most breathing in? It's not oxygen. It's nitrogen, yep. So Earth's atmosphere is mostly nitrogen. It's about 80-20, nitrogen and 20% oxygen. So anyway, so this is kind of what the Venus's atmosphere would look like. And I think on the video we watched on Friday, that's the only thing we did for Venus, it talked about the lightning, that Venus actually has a hydrological cycle, has a water cycle, liquid cycle because it's not water. So it has sulfuric acid instead of H2O, it's H2SO4. And so anyway, pretty cool. So here in a minute, we're going to talk about the greenhouse effect. So the Earth has a greenhouse effect. Earth has had a greenhouse effect ever since 4.6 billion years, okay? And what the greenhouse effect is kind of like a greenhouse. Maybe it's my next slide. No. Okay, well, I'll come back to the greenhouse effect if that's okay with you. That's a little bit more about Venus's atmosphere. Some of these slides are kind of redundant. I like this slide because of this figure right here. What happens on Earth with regard to how thick the air is if you climb a mountain? There's less air. It becomes thinner. Yep. And if you need to take in oxygen, which we do, it becomes harder to breathe, and you can adapt. I know athletes, when they prepare for playing in higher elevations, go ahead and condition themselves to less oxygen there. What's that?
Some athletes put on like oxygen masks when they go to higher altitudes, like Colorado or something.
They put on oxygen masks.
While they're warming up and stuff, so they can prepare.
Okay, perfect. So that's the same way with Venus. As you go up in elevation, so this is the ground, and you're going up in elevation, notice that, I know I misspoke the other day. As you go up in elevation, this one over here says what the pressure is. The other day I said the pressure on the surface of Venus was, I think I said about 200 times the pressure on the Earth. But actually it's about 90 times the pressure on the Earth. And so that might have been one of the things that got Venera, the Soviet spacecraft. That landed on Venus. So 90 times the atmospheric pressure we feel. So how hot is it on the surface of Venus?
900? Sure.
About 750. We're going to see 750 Kelvin. I don't know what that would be Celsius. That'd be about 900 Celsius. So it's very hot on Venus. Now, do you guys remember? I'm going to mix up planets here. I'm switching from Venus. What's the planet inside of Venus? Close to the sun. Mercury. So do you remember the thing about Mercury, the daytime temperature and the nighttime temperature?
700 and negative 100.
Something like that, yes. Yeah. So we'll go 700 and negative something 100. So the nighttime side of Mercury was so darn cold. Why was it so cold? There's no atmosphere, that's right. The other reason is it rotates so dang slowly. Yep, both of those things. Well, such is not the case on Venus. On Venus, everywhere it's about 750 Kelvin. And that has to do with kind of the carbon dioxide and the greenhouse effect I'm going to talk about in a minute. The thick atmosphere. Nope, there it is, 700. I knew I saw it earlier today. All right. So here finally is the greenhouse effect. Now on Earth, honestly, sometimes we'll call a greenhouse effect and then we'll call it the enhanced greenhouse effect. Enhancement, of course, meaning that it's been brought about by not necessarily natural circumstances. But the Earth has had carbon dioxide in its atmosphere, along with nitrogen and oxygen, but Earth's atmosphere has kind of morphed over time. Carbon dioxide is notorious for actually trapping heat. So this is the surface of Venus, could be the surface of Earth, okay? And the thing about it is the sun shines on Venus and the clouds allow the sunlight to come through. The sunlight interacts with the surface of the planet, in this case Venus, could be the Earth, and then it actually is radiated away into a different energy, a different wavelength. We'll be talking about light, and this is going to be heat coming up. But so the light comes through, and then the heat actually is blocked by the presence of carbon dioxide and other gases in the atmosphere. Methane on Earth is definitely a player. So that's the greenhouse effect. The reason they call it the greenhouse effect is kind of like if you have a greenhouse. I've never had a greenhouse, but if you walk into a place that's selling plants, okay, what do they have for their walls and their ceiling and everything? It's glass, exactly, it's glass. And so kind of like the atmosphere, glass will allow light to come in. That light interacts with stuff in there, okay? And that light, visible light literally is turned into a different energy we call heat or infrared radiation, and that's the wiggle out, infrared radiation. And then the windows block the infrared radiation from leaving. Your car's the same way. On a sunny day, you got black interior in your car. Yeah, it's gonna get very hot in there. If it's not a sunny day, okay, not so much of a deal, okay? So it's the same thing. All right. So this is why we kind of have this contrast already between Mercury and Venus with regard to their nighttime temperatures. Nighttime temperature on Mercury, very cold. It's so close to the sun. Nighttime temperature on Venus, it's pretty hot. It's like wearing your blanket in the daytime and just leaving it on at night. So, Venus, it's geologically active, but in somewhat, I would imagine, they always say they get to, what's the core of a planet look like? I don't know. But they get to the core, information about a core of a planet kind of like we do on Earth, which is seismology, kind of looking at vibrations through the planet. So it's got some liquid in it, but it doesn't have a lot of pockmarks. It doesn't have a lot of bombardment craters. Now we saw like volcano craters, but we didn't see bombardment craters. And so it's thought that those bombardment craters, like you see on Mercury, and you see those little pockmarks on the moon, that those actually have been resurfaced over time. And and it looks like maybe periodically, every 700 million years or so, basically the heat builds up underneath the crust in Venus, and it goes ahead and it just basically melts its entire surface. So it melts, and then it cools down and re-solidifies. So I think that's kind of, it does not have plate tectonics. It has in the past has had tectonics, but not plate tectonics like we're used to. More interesting facts. Okay. What else? What do we got up here? It looks like its core is similar to the Earth, made of iron. What's the symbol for iron? Fe. Very good. Fe is a symbol for iron. It's got an iron core. We're going to see that if I put Fe and I put an L in parentheses, I know you guys aren't, this is chemistry, but what phase could that mean after the iron? Liquid, yes. If iron is L, liquid, and actually that allows for an important feature associated with planets called this is my magnetic field. Does Earth have a magnetic field? Yes, you betcha. Okay. Now Venus doesn't have a magnetic field, but it's thought maybe because it rotates so slowly that that's why it doesn't have a magnetic field. It should. Let's see. All right, here's one for you. So when I look at the plane of the ecliptic, here's the sun. What sort of direction does everything spin and orbit? All about counterclockwise, yeah. And I think I mentioned this the other day that when we get to Venus, if you look at the North Pole, it's actually rotating clockwise, spinning clockwise. It's kind of like walking and chewing gum at the same time. So it's spinning clockwise, but it's orbiting counterclockwise. Okay. So, and I read on some of y'all's papers that actually could most likely occur as early on in when our solar system was young. We had a whole bunch of kind of things floating around that smacked into other things, and it could have got, as it was forming, whacked. And actually, its axis of rotation was tilted. Because do you remember how many degrees is it tilted? Almost 180, like 177 or something like that. Yeah. So that's one interesting thing. Let's see. Oh, seasons. So why does Earth have seasons? Yeah, tilted. And so the fact that it's actually 177 degrees means that it only is like tilted 30 degrees from being perpendicular. So it basically has no seasons. The next planet we're going to talk about does have seasons. All right. So let's take a look at what's the next planet. Oh, we're going to skip Earth for now. Next planet, Mars. Yes. We'll go ahead and hopefully my sound will work and we can check out this. Mars. Wait. Okay. To know when you're looking at stuff in astronomy, whether it's like a figure, like an artist drew it, or whether it's a real photo. And I would say that pretty much all of these Mars ones are photos. Okay. I have a link that I'm going to take you to either today or Wednesday about the different missions that have been to Mars. But this, let's see, Spirit. Now, if you go look up about Spirit, actually there's Spirit and it's got a fellow rover. Spirit actually got stuck somewhere in its these are solar panels. The arms are solar panels. And so the sun couldn't get to it, so Spirit kind of is out of commission. Okay. So you can kind of see the little marks that Spirit left. Doesn't that almost look like a place on Earth? I think. It's amazing. Have you guys ever gotten that email on Facebook that says that Mars will be the size of the moon? I get it all the time. And actually, back in 2001, it wasn't the size of a moon, but it was fall, what I remember. I know this says June, but it was as close as it was a pretty close pass. Okay, so if this is the sun, we have Mercury, Venus, Earth, Mars. So sometimes, we're kind of close together, so it didn't look like the size of the moon. So there's some myths in here that I'd like to bust. That's one of them. Mars will never look like the size of the moon. Another one was, can you ever see the moon in the daytime? Yeah. Another one is, if you see a meteor streaking through the sky, was there a star that really fell? No. So 3. Okay. So what did the video say? What are these regions? Polar ice caps, exactly. And he called it dry ice. Anybody know what dry ice is? What chemical it is? You guys told me a minute ago. It's actually solid CO2. Like dry ice. If you go to Hy-Vee to get some dry ice, it's CO2. I'll put an S there. Yep. So, another picture. So this is from Pathfinder. And I just think the engineers, it must be such a rush to work for NASA. To think of these things take years, not to mention the funding, but the scientists that this is their life, to engineer something that will make it to Mars. And so this was like the little pod thing that the little rover came in. If you read the caption I did this morning, this is about the size of a microwave. And see the name, that rock is called Yogi. And it's like you get to name things that people have never been to before. I just think that would be so cool. Mars is a busy place.
Is Boo Boo right next to it?
I don't know. Boo Boo Yogi could be. So crater over here. Now you can start to see, and we talked the other day about an iridium level, kind of showing us that going back in time, about 65 million years ago, the Earth was struck and a layer of iridium was put out by the object that struck the Earth. But anyway, I kind of think of that. Can you kind of see this layering? Now, Grand Canyon. What made the Grand Canyon? What made the thing in the rocks?
Colorado River.
The Colorado River is what I was thinking about. The erosion from the Colorado River. Yeah.
Paul Bunyan.
What's that?
Paul Bunyan.
Paul Bunyan? No. But we definitely see our fair share of erosion on Mars. This actually is a chunk of rock from Mars that landed on the Earth. What do we call it? Starts with letter M. Meteorite. Yes, meteorite. And how do we know? I think I've just mentioned, I haven't given details, but how do we know that this came from Mars? A lot of iron in it. That's kind of getting my point. It's the chemical composition of it. Yep. So we saw this before. This is showing the 2 hemispheres. They're definitely different. And again, it's top topographical. The dark blue is low and the pink and red is high. All right. A favorite test question is features on the planets, and a feature on this planet is Olympus Mons. Do you remember what state that, it's a big old caldera, and on the video they said it's the size of Arizona. Very good. Then this one says Missouri. I don't know if that's a difference between the two, Arizona, Missouri. Okay, but it's humongous. This slide says that up here, it's a shield volcano, up here, that this is about the size of the city of LA. It is crazy. This is a big scar. It looks like a scar. And to me, it's located, if you see pictures of Mars, it's kind of along the equator. It's a break, and it actually has to do with kind of the cooling of Mars. But it's called Valles Marineris. It's another feature that a lot of times will make it to my tests. Valles Marineris. Now, I like the video because one of the 25 facts that they talked about was a canyon, not this one, but a canyon that was similar to the Grand Canyon on Mars. But this one goes basically across, as I understand it, this would go from, from our west to our east coast on Mars. Martian landslides. This is a picture from the Viking orbiter. And hopefully you can maybe kind of see these wispy sort of things. These are kind of some older landers. Viking 1, Viking 2, and Pathfinder. Viking 1, when it landed back in the 70s, everybody was really excited because it actually had a little chemistry kit in it. And it and we've done this since Viking, but it took some of the Martian soil and it did some chemicals, and it was like, oh my gosh, that has, I can't remember the reaction, but it was positive for life, basically. And then they got to looking and thinking about it, and actually, it was a poor test in the first place, basically. So, it looks like Earth, I'm telling you. Water frost. This was taken by Viking 2. I've got a little animation to show you. Dust storms are crazy on Mars. I have some friends at the observatory who are really into looking at Mars. Now, when I look at Mars with my eyes, I'm not patient enough. Whenever you get to a telescope, take your time. Okay, kind of soak it in. But actually, if it's in focus, you can see some features of Mars even. And they'll have a map in the observatory and they'll kind of show you. But anyway, the dust storms are crazy. Dust devils are crazy. So check this out.
They had like